put this guy over on this other screen. Okay. So we're going to start with learning some new identities today. So our first one is called the co-function identities. Back when we first did, it was the day we did the 30, 60, 90 and the 45, 45, 90 triangles. We hopefully noticed, we kind of pointed out there's a relationship between the ones that add up to 90 degrees, right? There's the sine of 30 is the same as the cosine of 60. They come out to be the same number, and 30 and 60 add up to 90. We know very well that 45 and 45, sine of 45 and cosine of 45 are the same number. They add up to 90. So that's what these co-function identities are saying. They're saying, and remember, 90 is the same as pi over 2 in our radian world, and we're going to work in radians at this point, okay? So we're making that hard transition right now. So sine of pi over 2 minus u is the same as saying cosine of u. They're interchangeable. So if they give me sine of pi over 2 minus u in an equation, I can take that out and I can substitute in cosine of u. Okay. All right. Cosine of pi over 2 minus u is the sine of u. All right. And then the tangent of pi over 2 minus u, surprise, surprise, is cotangent. So they almost go with the reciprocals, not quite. And then cotangent would be tangent. Secant is the cosecant of u. And then cosecant is the secant of u. All right. There are also something called even and odd identities, okay? We actually have functions that are even and odd as well. And the way we tell if a function is even or odd is if we plug a negative x, or in this case, a negative u in, all right, and we get the positive of the original function, we know it's even. If we get the negative of the original function, we know it's odd. If it comes out really neither positive or negative of the original, then it's neither positive or even or odd. So our cosine and our secant are the only ones that are even. So when we put a negative in on these two, we get a positive out. So basically, it switches to a positive sign in front, okay? When I put a negative into sine, cosecant, tangent, and cotangent, I get the negative of the original function because they're considered odd functions. All right. So we are going to use these today to help us with our to help us with our solving for our trig functions. Okay. So the first one, it has the sine of pi over 2 minus x. So we just talked about just a minute ago, what am I going to substitute in for this? Can you tell me that in the chat? Look back up at what we just wrote down. What am I allowed to substitute in for that? What do you guys think here in the room? Good. Waiting for my chat here. Okay, so we are definitely going to be able to pluck out. Really what they just did was they wrote a really fancy or hard way to say cosine of x, right? And because I have an x in the problem, I would use an x. They're used u kind of as a dummy variable in the formulas, okay? So we're going to say this is the same as cosine of x equals 8 over 17. Oops, 17, not 7. All right, so now that I know that, I'm going to go back to what we were doing yesterday. All students take calculus, okay? So my first thing I need to identify is it looks like cosine is positive. Can you tell me in the chat, when is cosine positive? Which quadrants? What do you guys think here in the room? Which two quadrants is cosine positive in?
First one and fourth one?
Yep. Thank you. First and fourth. It's okay. I'm not scary, I promise. All right. All right. Oh my goodness, I've got all kinds of stuff going on here. So we're looking at We are all over the place today. Let's review this. Okay, so remember that they are all positive in quadrant 1, okay? In quadrant 2, only sine and cosecant are positive. Everything else is negative. In quadrant 3, tangent and cotangent are positive. Everything else is negative. And in quadrant 4, cosine and secant are positive. Everything else is negative. All right. So we have 1 and 4 is where I get to pick from. So I'm looking at 1 and 4. All right. The sine. So now we're looking at sine. Sine is positive. So based on the fact that we've got 1 and 4, all right, are the ones we get to pick from, which out of 1 and 4, where is the sign positive? Tell me in the chat. What do you guys think here in the room? Good job. All right. All right. Everybody got that one this time. Everybody got that one. Is definitely 1. All right. So I know all my answers should be coming out positive on this. All right. We're going to use the same identity method that we were using yesterday. The very first one we want to do is reciprocal if we can, right? Those are our freebies. So what is the reciprocal of cosine? Put it in the chat. What do you guys think here in the room? Reciprocal of cosine, if you don't know, up here the yellow sign tells us. Good job. Okay, so we know that it is secant of x equals 17/8. Perfect. All right. What is the reciprocal of sine? Tell me in the chat. What's the reciprocal of sine? What does everybody here in the room think? It's not cosine. Cosecant. Good, 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 good. Cosecant of x equals 17/15. And then if you guys notice up by the flag, there's the other one that's kind of a good reference. I know it's the SOHCAHTOA, but it's sine over its reciprocal, right? Cosine over its reciprocal, tangent over its reciprocal. All right, so we're only missing, it looks like, tangent and cotangent. So we have a choice on what we're going to use, okay? We can either use the quotient identities or the Pythagorean identities to get to cosine, or to get to cotangent and tangent. So tell me in the chat. I want to vote. What do you guys want to do? Do you want to do P for Pythagorean or Q for quotient? What do you guys think? Vote in the chat. Oh, we've got a lot of people who, we've got it's kind of going both ways. But I think I'm seeing more Qs than I am Ps, okay? You can do it either way. We'll see if we have another one that we'll do Pythagorean later, okay? We'll maybe do the next one by Pythagorean. Actually, I take that back. Let's do this one Pythagorean, and we'll do the next one quotient, okay? Because the next one looks a little ickier than this one. All right. So if I'm going to do Pythagorean, I need to find something that has a tangent in it. So I'm going to go back up and look at my identities from yesterday, or you can look at the pink sign, okay? So look up at the pink sign if you're here in the classroom, or if you remember the text from yesterday, that right there has a tangent in it. So I'm going to use 1 plus tangent squared equals secant squared. All right. So sometimes I'll just write out what the formula is really quick. 1 plus tangent squared equals secant squared. Do you notice how that one says it's? You can, if you want to, if you're going for memorization, sky, it's, ick, okay, are the first letters of all those formulas. All right, so 1 plus, I don't know my tangent, so tangent squared of x equals, I need my secant, which is this guy right here, 17/8, and we're supposed to square it. All right. I also have, for my people who are sitting here in the room, a couple of charts that have all the square numbers on them. Do you guys see them up? There's one on this side and one on that side. So you guys can help me out here, okay? Because my arithmetic is terrible. All right. What is 17 squared, everybody? I heard one person. There we go. Okay. What is 8 squared, everybody? 6. I've been waiting all year to hear that, you guys. Okay. Javier, thank you for keeping up. All right. I was talking to the room. They were helping me out, but I appreciate the help in the chat as well. All right. So I'm going to work smart and not hard, right? we want to take that 1 and we want to turn it into something with a common denominator of 64. So I'm going to write it as 64 over 64, even though it looks gigantic, right? Even though it looks gigantic. All right, I'm making sure that we're... Okay, so now I'm going to go ahead and I'm going to subtract that 64 over. So that gives me tangent squared equals... I've got to do 289 minus 64, which would be 225, which is really no surprise because look, I have a 15 hanging out here. That had to be my other number that I'm working with. I'm going to take the square root of both sides. Technically, it's plus minus, but we already determined that all the signs are supposed to be quadrant 1, so we're just going to keep the positive. I'm going to take the square root of 225, which is 15, and take the square root of 64, which is 8. So tangent is 15/8. All right. In the chat, I want the number answer this time. So what is our cotangent going to be if tangent is 15/8? What do you guys think here in the room? Good. All right, I'm seeing a lot of 8 over 15s. Perfect. All right. The next one I think is slightly uglier, but we'll get through it. All right, I'll leave it there for a couple seconds. Let you all catch up. Okay, example 6. All right, so this time, notice it's the even odd. So remember we had the 2 that we talked about at the beginning. We had the co-function and we had the even odd identity. So I'm going to look at the even odd with this one. And then it kind of proceeds like we did yesterday. We add on to what we had yesterday. So when we have a cosine of a negative x, I know that I can replace this. If I go back and look, I replace it with just cosine of x. So again, they gave me cosine of x equals 2/5. I substituted in. Okay, this one definitely looks a little bit uglier, doesn't it? It's not as pretty. Okay, so I'm going to go back to all students take calculus. Hopefully we're a little better at it this time than we were on the last one. All right, so I know that the cosine is positive. So tell me in the chat, which 2 quadrants is the cosine positive in? What do you guys think here in the room? Much better than last time. Good job. Waiting for my chat. Okay, so 1 and 4 is where we're at. Okay, then it looks like the cotangent has to be negative. So out of quadrant 1 and 4, those are my only 2 choices. Which one is the cotangent negative? Put it in the chat. What do you guys think here in the room?
4.
Good job. All right, so we're definitely, let's see, I'm waiting. My chat's going the right way. 4. I like how we're all some of us have stuck hard to those Roman numerals, and then a lot of us have switched back to the 4s. But it's okay either way. I know what you mean. All right, Andy was in here yesterday afternoon telling Roman numeral jokes, but I don't remember what they were. So he was paying attention to the 6th period lesson, and then I don't know. Oh, you guys aren't in 6th period. Because that's a trig class. He was telling Roman numeral jokes. All right, here we go. So reciprocal of cosine. What's the reciprocal of cosine, everybody? What are you guys thinking here? Good. I'm waiting for my chat. What's the reciprocal of cosine? I'm getting all these quick responses here in person now. I'm impatient in the chat. Okay. Secant of x equals 5/2. Perfect. All right. What's the reciprocal of cotangent? Tell me in the chat. What do you guys think here in the room? Tangent. Good. That's the easy one, right? Because they sound the same. All right. I saw a whole bunch of tangents. We've got x equals. I'm going to take this guy here and I'm going to flip him. So 21 over -2 square root of 21. This one is this is ugly because basically you're taking one that's already been rationalized, right? And we're going to have to basically what I would say is unrationalize it. So I'm going, but it's really still rationalizing. So I'm going to rationalize it maybe it will make it look a little bit better. So let's see, 21 square root of 21 over -2 times square root of 21 times square root of 21 would just be 21. And then you'll hopefully notice that these cancel and we get negative square root of 21 over 2, which looks better than it did originally when we flipped it, right? Okay. I promised we would use the quotient identity, right? So let's do the quotient to get our sine. So in terms of sine and cosine, what is tangent? So what is the quotient identity for tangent? Tell me in the chat. What do you guys think here in the room? Purple sign. What's tangent say? Yeah, we've answered that like 5 million times, right? Because we do it on the unit circle all the time. It's like the first one we use. We got one person in the chat, 2 people in the chat. All right, 3, 4, here we go. Okay, so sine over cosine. So I'm going to take the sine. Oh, I don't have the sine. That's what I'm trying to find, right? So sine of x divided by the cosine 2/5. But guess what? I should have put my tangent in over here, right? That value. So I should have put in negative square root of 21 over 2. All right, this is going to be a little bit weird, okay? We're used to, when we take a fraction and move it to the other side, we're used to flipping it, right? But that's usually when it's under multiplication. When we're under division right here, we're going to actually just take this whole thing and multiply it to the other side. So let me write out what that looks like. So 2/5 times negative square root of 21 over 2 equals sine x. And we like that because look at what happens with those 2's. So we get that it's negative square root of 21 over 5, which makes sense. Sine is supposed to be negative in quadrant 4. Okay. The other one we get for free now is we get our cosecant. We're going to flip our sign to negative 5 over square root of 21. We're going to go ahead and rationalize that. So negative 5 square root of 21 over 21. All right, the last, believe it or not, 5 examples are super quick. Okay. Are we on time? 41. Are you all excited about getting to do the fire drill today? You did not luck out. 6th period. Oh. When it's hot. I think first period, no, what was it? 2nd period, we did it in the rain on Monday. That was our favorite day. Even though it was a little bit soppy out there, it was still better than yesterday's 5th period. All right, we are going to match the trig expression with one of the following. Okay, so this is kind of the fun part about trig. Okay, yes, trig is fun. Okay, it's kind of like putting a puzzle together. All right, you have to manipulate the trig identity that's there to get to one of the answers. Okay, and you might try something and it might fail, and that's okay. You just try again. Okay. The first thing I look for is if I can put it in terms of sines and cosines, I do that. If I see things that are squared is a trigger for a Pythagorean identity. Okay, so I'm going to go to Pythagorean identities first if I see something squared. Okay, and look at what our goal is to get it to. Look at how simple we're going to get it. We're going to get it to be one of those 5 things. Okay, so I'm looking for things, and I'm looking for things where I can create a denominator and cancel with something that's in a numerator sometimes. All right, so let's start with this one here. Cosecant is the reciprocal of what? Tell me in the chat, what's cosecant's reciprocal? Good. Okay, perfect. It's sine. But we've typically up to this point we just flipped the numbers, right? We don't use it like we wrote down the identities yesterday. Remember how we wrote that down yesterday? We wrote it down to look like 1 over sine. So that's what we're going to use in this context, is 1 over sine. All right, so let's go back to here. So I'm going to replace cosecant with 1 over sine of x, and then we're just going to drop the sign down. Our favorite part about math. What do we get to do now, everybody? Tell me in the chat what's going to happen. What was that, Cole? Yep, good. Okay, we get to cancel them out. That's right. Our favorite part about math. And look at that. We got an answer of just 1. When we are doing these problems, the chunk that looks like the trig, it acts like a variable. Okay, so you just got to think about it kind of in the context of secant, cosecant is a variable. What can I do with that variable, right? I can apply all my algebraic properties to the trig piece, just like I can apply them to variables. Okay. All right. Looking at number 8. All right. I think we're probably going to have to do 2 things. So look at your purple sign, or if you're at home, go look at your quotient identities that we wrote down in the left-hand column. Right here, what's another name for cotangent in terms of sine and cosine? So look at the purple sign. What does it say? Tell me in the chat. What do you think we can write for that? Think quotient. What do you guys think? So what's the purple sign say? What does it say on cotangent? Cosine over sine. Okay, so I'm going to replace cotangent with cosine of x divided by sine of x. Good. Now I'm going to replace secant with something and see if we can get some magic to happen. Okay, so secant I can't write like a sine over a cosine, right? But what is secant's reciprocal? Tell me in the chat. What do you think the secant's reciprocal is? Here in the room, what do you think the reciprocal is? Good. Okay, but now we're going to write it in our new fancy way. I'm seeing cosines in the chat. We've got 1 over the cosine of x is the way I would write that. Okay. Do we see some stuff that's going to cancel? Look at that. We love that part, right? There's a little bit of a catch on this one, though. I'm going to set, I have a 1 left in the numerator and a sign left in the denominator. But that's not one of our 5 choices. Go back and look at these 5 choices. I can't do 1 over sine. I have sine, but not 1 over sine. Look at your, I saw one person flip their head this way. Look at the yellow sign again. What's 1 over sine the same as? Cosecant. It's a good job. My chat is keeping up. Nice job. It is the same as cosecant. So I can replace, I know when I see this, I get to substitute in cosecant x. Okay. It's all about just being able to keep substituting in. And you're going to substitute in multiple times in one problem. Okay. All right. Matthew, thank you for the equation there. All right. Example 9. Actually, let me give you a couple seconds there. I need to put the mask on. I don't go through the whole thing of water the entire period like I used to. All right. So let's look at example 9. We're only going through 11 today, so we're almost done. So when I see squared things, I think about the Pythagorean identities. Okay. So I am looking for something that says secant squared or tangent squared. All right, so I'm going to have to explain this. Those of you who are in the classroom, I'm going to explain it 2 ways. Okay, so if you got the text and you're looking at the picture that I sent yesterday, you can do that at home. And I'm going to explain it 2 ways so that those of us at home have some context for this. If you're in the classroom here, look at the pink sign. Look at the middle row, right? That's the one with secant and tangent in it. Do you see how the first one says 1 plus tangent squared equals secant squared? So for secant squared, I can substitute in 1 plus tangent squared. Does that make sense? And then if I had, like, if you look at the third one, if I wanted to substitute in for tangent squared, I could put in secant squared minus 1. All I did was subtract over the 1 from the first equation. Okay, so I'm going to explain that again in the chat. But basically, I've got that sign set up, so all you have to do is look at the sign for the substitution. Okay. All right. So those of you that are at home, we're looking, the sign we're looking at says 1 plus tangent squared equals secant squared. Okay. All right, so I want to substitute in either for tangent or secant. And the good news is it's already solved for secant, so I can take this and I can just directly substitute that in for secant. If I wanted to substitute in for tangent instead, I could manipulate this equation that we have and I could take that 1 and subtract it from the other side. So I could go tangent squared of u equals secant squared u minus 1. So I can take that and I can manipulate it as I need to. Okay, I'm going to go with just the direct substitution in. So we've got tangent squared of x minus, and then I'm good. You always want to put parentheses. Okay, whenever you have a minus sign and you have to do something after it, you always put parentheses. It's a habit you need to start now if you don't already do that. All right, it's so important for next year. So 1 plus tangent squared of x. All right, we're going to put our algebra hats back on. In fact, we're going to put like our 7th grade hats back on. Okay, what do I have to do next? What's the algebra I have to do next? Tell me in the chat. What do you guys think? What do you think here in the room? What do I got to do? Yep, good. I'm waiting for my chat. Okay, we're seeing our distribute coming in. Good. So we've got tangent squared x minus 1 minus tangent squared x. Now we are back into good old combining like terms. How nice is that? We're doing some awesome trig here, and we're combining our like terms together. This one and this one cancel, don't they? So my final answer is -1. Isn't that one of the things that was up here on that list that I wanted to get originally? Isn't it amazing that we took that thing that looked ugly, right? Tangent squared minus secant squared, and we got a -1 out of it. Okay. All right. We'll look at the next one. All right. So cosecant, well, I'm seeing squared things, right? When I see squared things, I go to Pythagorean identities. Okay. So if you're here in the classroom, I want you to look up at that sign. Okay. I want you to look for something that says cosecant squared minus 1. Okay. If you're at home, I want you to find the Pythagorean identity that has a cosecant in it, cosecant squared in it. Okay, what do you guys think? What can I replace here in the classroom? Okay, we're looking at the bottom row. Look at the one in the middle. What's the same as cosecant squared minus 1? What's it say? It's not that hard. What's it say? Thank you, Lauren. Okay, so cotangent squared. I'm going to show everybody at home how we got that, but I want to make sure I'm going to separate this a little bit. Okay, so what we were doing here in the classroom is, and what you have access to at home, is we know that 1 plus cotangent squared of u equals cosecant squared of u. Okay. I want to try to get rid of that one, the square, the binomial, right? I want to try to turn it into a monomial, basically. So I can't just substitute in for cosecant. I guess I could, but I am going to try to get what I'm going to try to substitute in for this whole thing. Okay. So I recognize when I move that over that I get cosecant squared u minus 1. This is exactly this, so I can directly substitute cotangent in because it's equal to cotangent squared. Okay. Now, I'm still not simplified enough. Okay, so I'm going to go use my quotient identity. So if I go look at my quotient identity, the purple sign, if you're here in the room, what's another name for cotangent? We're not worried about the squared right now. What's cotangent? In terms of sine and cosine, tell me in the chat, what's cotangent? All right, good job. Good job, good job. All right, I'm seeing lots of cosine over sine. So as long as I have that cosine over sine, since I have a squared, I need them to both be squared. It's like I'm substituting in 2 of them, okay? So I would say cosine squared x over sine squared x times 1 over cosine squared x. All right, our favorite part about math. What do we get to do now? What do we think, you guys? What do we get to do? Awesome. All right, I'm waiting for my chat to come through. All right, I'm seeing a lot of cancels. Awesome, awesome, awesome. So we got 1 over sine squared x. All right, that's not one of my choices. Go back and look at those 5 choices that we had. Which one of those do you think it's going to be? In the chat, take a guess. What do you guys think here and there? Which one? I got 1 over, it was cosecant, right? No, 1 over sine squared. There you go. Good job. All right, nobody in the chat's guessing. So it would go back to the reciprocal, right? The reciprocal of sine is cosecant, so it'd be cosecant squared x. All right. I've done a lot of problems with you. What I want you to do is number 11 took it back like 10 notches compared to what we've been doing. Okay, this is more like the first one we did, which was like 7. So I want you to take a minute of think time on your own, and I want you to try to simplify example 11 on your own. So everybody's going to do it. Nobody's going to type anything into the chat yet. Okay, so everybody take a minute and simplify. Okay. Okay. I want you to just put the answer you got in the chat. I don't care if it's right or wrong. Put the answer you got in the chat. If you're here in the room, go ahead and put it in the chat this time, okay? I want to see what everybody's thinking. Everybody put your answer that you got in the chat. Curious where we're at. And again, it doesn't matter if you're right or wrong. I don't care. All right, I'm seeing a lot of sine x's. All right, so let's see. Tangent would have been sine x divided by cosine x, and then times cosine x. These cancel. I agree with sine x. Okay. All right. Hopefully it wasn't too bad today. All right. We're going to see if I can find my Andy's joke of the day here.